Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to go into the different formulas for the deflection of the beams. So here we see the simply supported beam with the different loading condition, and accordingly we have different deflection formulas. You see here on the right side the different deflection formula depending on the load condition on the beam. So we see here, starting from the first case, we see a simply supported beam with a pointed load acting on the beam, and the total length of the beam is L. So we can find the total deformation or the deflection of the beam, which will be here at the mid of the beam, and this will be sigma maximum. This maximum deformation can be found out by this equation, PL cube divided by 48 EI. Now in this case, P is always the unit of the load, I mean the pointed load, L is the length of the beam, total length of the beam, and 48 is the constant, E is elasticity of the material, and I is the moment of inertia. So in similar way, there are different formulas used here, but I will explain one example here to show how to find out the maximum deformation. You keep in mind that when their load P is acting not in the middle of the beam but at certain point A from left end and B at the right end, then you can find the maximum deformation by this formula. Similarly, when the uniformly distributed load is acting on the beam, then you can find the maximum deformation by this formula, where W in this case is the uniformly distributed load. Similarly, in this way, you can find the maximum deformation for a triangular load acting on the beam by this formula, and when there is a load like in this triangular form, then you can find the maximum deflection by this method. Now let's suppose take this one example, and we are going to find out the maximum deformation for our number one case. And then similarly you can use this method to find out the deflection for the other beams. So it is a beam. If I remove these all things here, so the load is acting at the mid of the beam. It means from here L by 2, and from here it is also L by 2. So the load P, for example, let's suppose P load acting on the beam and it is 4 kilonewton. This load acting is 4 kilonewton. We just take an example to show how to determine the maximum deflection. L is the total length of the beam. I mean, in this case, let's suppose the length of the beam is 5 meters. This is just an example. Now, let's suppose there is a steel reinforced concrete and the elasticity of the material used is 200 megapascal, or we can say 200 multiply 10 to the power 6 Newton per meter, Newton per square meter. This is the elasticity of the material used in this beam. And cross section of the beam, for example, this is a rectangular beam or square beam. B is 0.5 meter is the width of the beam, and there is a height or depth of the beam which is equal to the also 0.5 meter, let's suppose. So now how to find out the deformation for this case when the load is acting in the middle? So you have to put these values here in this equation. So this equation we are going to use here. So P L cube divided by 48 into EI. Now P is the pointed load which is 4 kilonewton here, 4 kilonewton, but I'm going to change into Newton because this elasticity is also in Newton, so that's why I'm going to multiply with 10 to the power 3. So now it will be in Newton, multiply with the length of the beam, which is this length is 5 meter of the beam, dividing by 48, multiplying with the E elasticity of the material. We know that it is given to us, for example, it is 200 megapascal Newton per square meter. So it will be like here, like in this way. And now I is the moment of inertia for the square beam. So the moment of inertia for the square beam can be found out BH cube divided by 12. So or BD cube by 12, while here is the depth. B is the width here and H is the depth here 0.5. So 0.5 into 0.5 cube divided by 12. So from this we will get the moment of inertia for this beam. So we will get here after calculating 0.00520 meter 4. So it is the moment of inertia of the beam. Now putting this value here into moment of inertia, it is EI, so I is 0.00520. So it is a moment of inertia, so we will find out the maximum deflection of the beam. And sorry, one thing I forgot here, that it is PL cube. Keep in mind it is L cube, yeah, so that's why I have to put it here 5 cube, because the length in this formula is power to the 3, so I also put it power to the 3. So by calculating I will get the maximum deformation. So I put it in my calculator and found out here 0.0100 meter, or if we multiply this with 1000, we will convert this into millimeter. So 10.01 millimeter is the maximum deflection in this beam. So by this way we find out our maximum deflection in the beam. In the similar way you can also use this formula to find out the deflection for this case, and this formula you can use for this case, similarly this one for this case, and similarly this one for this case. So hope you guys understand today's lecture, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.